Hello, everyone. I hope that the audio is better than last week. Well, I hope it works. Um, and I think it might be better than last week, but we'll see. I'll start in 5 minutes as per, I said on my post, but I'll just go through some just basics before I start. Very good. I'm making sure everything's good. So I am offering private tutoring still, so you can have a look at my website, www.econhelp.com.au, if you would like private one-on-one tutoring. Live stream additional videos, so additional information, sorry. So someone asked me in a comment this week, they're like, oh, they didn't know where to find information about my live streams. So you can go to my posts section of my channel. So I'm still kind of new to it. But if you look at the post section, if you go to my channel, that will give you details. I just post up there whenever I've planned a live stream. And if I don't know what topic I'm going to do, I'll suggest a topic, and then, you can comment if you want me to cover anything specifically. I think next time I do it, which might not be next week, but it might be the week after because I'm actually away, but I'll probably do Solo Swan, which is such a cool model Solo Swan. The next time I do it, because someone asked me to do a video on that. So I will advertise my take time to talk about my maths playlist as well. It's really close to my heart because I do think that everyone deserves to understand economics, even if they haven't had the privilege or the ability to be able to get on top of the maths. And I think that it is really possible for people to develop and to get better at mathematics even when they're adults. So I put together the playlist for individuals who are really struggling, so you can have a look again on my channel. I do also have, because today I'm going to do just the basics of demand. I'm actually away. If you guys, I have a few people who I know watch my stuff. Um, you know, if you have seen my previous live streams, I actually did some really interesting ones, and then I'm away this week, so I'm not at my home, and I thought I'm just going to do something easy. Well, not easy, but more fundamentals. Just go back to the basically. So the basics of demand, that's what I'll be talking about today. And I do have a guide, and I forgot about it until I was just thinking about the sorts of exercises that I might go through. So if you look at my Shopify link below, I do have a guide on demand, supply, and equilibrium, and there's lots of practice questions and answers, which go through, and notes on all this stuff that I'm going to talk about today. So today I'm going to do the basics of demand. I will just wait 2 more minutes just because it's 2:58 in my time, AEST. And I did say on my post that I would start at 3. So I'll turn the microphone off now for a couple of minutes, and then I'll come back and I can talk about demand, basics of demand. Okay, guys, thank you for such a nice comment online. I'm not sure if you're still online at KeliF, but that's so sweet. It's exactly why I put up videos, because I really think that everyone should have an opportunity to understand economics if that's what they want to do, and that's just so nice to hear. So thank you so much for your feedback, and everyone, from when I get comments, and it's so cool. So hopefully you guys can hear me. Because I changed my mic setup from last week. So, okay, very good. So what I'm going to think about today is the basics of demand. So demand, what are we thinking about? We're thinking about representing our consumers' behavior. We are, in economics, we're concerned with the allocation of scarce resources. So we're really interested in markets, right? Markets where goods and services are traded. And in that trade, we decide a price. And what do we need? Well, one half of that trade, when there's only two, when we only have consumers and producers, we're just going to put aside all the rest of the stuff that can happen for the moment. We can make our models more complicated later, but our consumers, that's really one important side of the market. So demand is what we use to describe their behavior. We're interested in, when we're thinking about demand, we're interested in the relationship between, when we're thinking about demand, we're thinking about the quantity, right? The quantity of a good that is demanded. And that's always going to be at some price. And here, demand, you'll often see, is willingness and ability, a willing and able to pay for a good. That's demand. We're willing to buy this good and we're able to buy this good. And here, when we're thinking about what demand is, the quantity demanded at some price, we have our two kind of core components of demand, which is the quantity that is demanded at some price. So when we think about ways that we can represent the consumer's behavior, we're really interested in understanding the relationship between price, we usually just have that as P, and quantity demanded, which is usually QD, sometimes just Q. That's quantity demanded. Okay, good. That's really what we're talking about when we're talking about demand. Okay, so we're interested in the relationship between price and quantity demanded of a particular good. As per usual, you can always ask questions in the chat, or leave comments on the video later if you're watching it later. And usually people just kind of join as they're in. We'll see. And you can ask questions, whatever you like. If you want me to talk about something in particular or something else, I can, I can take that on board. Okay, so demand, the relationship between price and quantity demanded. The most rudimentary way that we have to communicate information about demand is what we call demand schedules. And this is when we treat our data as not continuous but discrete. This is when we have discrete data. So this is really, we usually have a table, or sometimes in words. We have discrete, so we're not thinking about graphing using demand curves or smooth lines. We're not thinking about that. We're just thinking about discrete units of information. And what was our two things that we're concerned about? We're thinking about how much is demanded, that's quantity demanded, at different prices. So demand schedules, it's probably the most rudimentary way of discussing demand. So for instance, if I have Katie here, who's demanding apples. And if I wanted to think about a demand schedule for Katie, I could list all of the possible prices that Katie might face, say $1 per kilogram or pound or wherever you're at, $2, $3. We would list all of the different prices over which Katie has some positive demand. And we would think about the quantity demanded. And it might look something like this. Imagine You know, if the price was $1, then Katie would demand 50 apples. If the price was $2, then she would demand 45. $3, she would demand 40. And $4, maybe 30. Okay? So this would be a demand schedule. It tells us the relationship between different prices and the amount of apples that are demanded by Katie. Okay, can we see anything interesting here? Yeah, we see a pattern here. As prices increase, let me see how many people I've got. What do you think happens to quantity demanded? You can put it in the chat if you want. As prices increase, you can see the quantity demanded decreases. What's this? This is the law of demand. The law of demand. There is an inverse relationship or an opposing relationship between the price of a good and how much of a good is demanded. So the law of demand. There is a few ways to express this because there is actually one true account or one true situation where we might say the law is violated. So we might call it maybe not a law if it's violated, but you know, like we would say a law of physics cannot be violated or something like that. So we might say the tendency or the pattern, or you know, there is an inverse relationship between price and quantity demanded. There is an inverse or negative relationship. And this is really fundamental between price and quantity demanded. Quantity demanded. Okay, good. All right, well, what can we do with this demand schedule? Well, we could graph it. Like we could provide a visual representation of what's going on. So we might do something like this. We might have, you know, two axes. And when we have two axes and we're representing what's going on with demand, we always have price on the vertical and quantity on the horizontal. And we could think about representing what's happening in this table on our diagram here. So, well, our price is going to be high. So the highest price we've got is 4. So I'll put this up here. I'll check whether anyone's here yet. Hello, how are you? Yes, good. Yes, good. The vacation is good. It's good. So if you guys were, oh, from Sri Lanka. I want to go to Sri Lanka. I'm not going to be doing much travel like with the kids for a while because it's between the planes and everything's very expensive and everything. We've just been traveling in the car basically. So but I would love to. One day I will get to Sri Lanka. My mum really wants to go to Sri Lanka as well. I'll take my mum to Sri Lanka. So 2, 3, there you go. So I've got all my possible prices here. How are you guys going? Let me know in the comments. All the possible prices here. And let's see my quantities. My lowest quantity is 30. So and it's to 50. So let's do one of those things where we cheat on our axes. Do you guys still do this? Where we go like this, it's just going to be, there's the numbers here, and we're going to start at 30. And let's say 35, 40, 45, and 50. So we could represent, you know, what's going on. We could use like a bar graph if we want to, and so that could happen. We could also just mark the discrete points that we have here. So if the price is $1, if the price is $4, then the quantity is 30. So it might be something like this. And if the price is $2, then we go to 45. So, sorry, if the price is $4, then it's 30. If the price is $3, then it's 40. About there. If the price is $2, then it's 45. And if the price is $1. So it could be something like that. Actually, that's not a super good representation of demand. But that's not too bad. You know, that would be one way that we might. Why don't I like that one? Because of diminishing marginal benefit. It's okay. You know, that might be one way that we can represent what's going on in our demand schedule is through axes like this with a price quantity axis. Hang on, let me just check. Yep, good. So that's really the most rudimentary way that we would describe what's going on with a consumer in a market is through demand schedules, and then we might have a very rudimentary way of drawing out what's happening in a diagram. We have our law of demand, which is really important, which says that as the price increases, there's an inverse negative relationship between price and quantity demanded. So as the price increases, quantity demanded decreases, or if the price decreases, quantity demanded increases. Now, what's more common, however, is that we're going to represent quantity demanded as and price as continuous variables. So represent as continuous. In which case we are going to, or we can describe these through algebra. So we can describe the relationship between price and quantity demanded through algebra. And this is where we get our very famous, our demand equations. So let's go to the next kind of idea. So we have demand equations. Okay. And with our demand equations, we're going to, or our demand functions, we might call them, we're going to represent the relationship between price and quantity demanded using an algebraic relationship, and we're going to consider our variables as continuous. So I might have something like this. Again, I'm just going to think about Katie's demand for apples. So quantity demanded is equal to, let's say it might be 100 minus, or 120 minus P. Okay, here. And here we're just using mathematics. Hi, Simone, how are you? It's nice to see you. How's, you're from, remind me where you're from. Are you from Canada or Germany? I can't remember. Sorry. We're just going through, I'm just running through very basic demand at this point because I'm actually on vacation. It's my son's birthday. So I just chose a very easy topic, but we're going to go through just the basics of demand. So we can express them, express the relationship between quantity demanded and price using equations. And here we might see this sort of notation. And this is function notation. This can be really confusing for people. And it's very common for economists to use this sort of notation to just describe, I'm talking about a demand relationship. I'm talking about, and don't actually give the equation, but they just say QD of P. That's how you would talk about it, QD of P. This is using function notation, and it's just telling us explicitly that quantity demanded is being modeled as a function of price. So here it's just a reference, or it's a way of referencing a mathematical model. We're just saying this is our model of demand. We're representing quantity demanded as a function of price. Now, this way of understanding demand, we would call this a demand, like kind of demand proper, for lack of a better word. We would call that a demand equation. If we wanted to rearrange this, so, and I have done a video on this before, the video on function notation in my maths playlist. playlist, because this can be confusing for students. This is not a multiplication. Very good. Oh, thank you very much. Beautiful. Okay, very good. So math playlist. I'm not good with my flags, Simone. Sorry. I'll have to look. I'll have to look up what the flag. I'm sorry, I don't know your flag. Um, good. We could rearrange this until price is on the left-hand side. So if we took away 120 from both sides, or if we added P, that could, to both sides. And if we take away quantity demanded from both sides, we would get this sort of expression of our demand. And this is what we call an inverse demand equation. This is an inverse demand equation. It had price on the left-hand side. We are modeling demand where price is being modeled as a function of quantity. And you will see it, demand equations being expressed in both ways, either with price being modeled as a function of quantity or quantity being modeled as a function of price. And it's important to understand that these two expressions describe exactly the same relationship between price and quantity. It's exactly the same relationship. It's just a relationship that's expressed in a different way, one with price on the left-hand side and one with quantity. And depending on what we want to do, it will depend which form we prefer. Basically, that's really it. But students can get a little bit confused about this. Good. So that's a demand equation. We're taking quantity and price to be continuous. Now, a lot of people, this is an assumption that we're representing our variables to be continuous in this way. How realistic is that assumption? Well, it would depend on the situation. But, when we describe what our consumers are doing using mathematical equations, if we allow that to be continuous variables, it allows us to use a lot of mathematics, continuous mathematics. It just opens up a whole world for us. So I think that's the reason why we do it, even though it's likely not to be the case. If we're thinking about the quantity of iPhones, say, it's likely not to be the case that we can't have 1.25 iPhones. It's not a continuous kind of thing, but we will model it as continuous because it allows us to use the mathematics. Germany, sorry. It's been a long couple of days. We've been I don't know if you guys know it, when you go on vacation, sometimes it's like more tiring. Does that make sense? We actually don't call it vacation. I think I called it vacation in my post, but we would say holiday. Very good. So this is an inverse demand equation. P is on the left-hand side. So that's another thing about demand. Okay, so what were we talking about? We were talking about Katie's demands for apples. So just very rudimentary then, this equation allows us to figure out how many apples that Katie would buy for different prices. So we would say if the price is equal to, let's say, 50, the quantity demanded of apples is equal to 120 minus 50 is equal to 70. We can put in any number of prices here, and that would tell us how much is demanded at those prices. We could also do it the other way around and think about, what would the price be in order to motivate the consumer to demand a specific amount. So let's say if we want the quantity demanded to be equal to 100, what's the price associated with that? Well, we would substitute QD is equal to 100 is equal to 120 minus P. So we can solve for that. We can take away 120 from both sides, or then multiply by -1, or we can add P to both sides. Let's do it like that. 100 plus P is equal to 120, and then take away 100 from both sides, and we would get P is equal to 120 minus 100 is equal to 20. So what does that tell us? That tells us that if the quantity is 100, then the price must be 20. Now, we can draw it out as well, and we will get our demand curve. And this line is going to tell us, again, we're thinking about the relationship between prices and quantity. Let's see. Very good. Now, here we have an axis. Again, quantity demanded is always going to be on the horizontal axis, and price is always going to be on the vertical axis. Now, we know from our axes at the origin where they both meet, that's where both of them are equal to 0. And as we go up like this, price increases. As we go across like this, quantity demanded increases. So we also know, well, I can tell that, if we're thinking about drawing the equation of drawing any equation really, we can think about the place where the line crosses the vertical axis. This point associates where quantity demanded is equal to 0. Okay, so we have I'll just write that here. The vertical axis intercept, what we call the vertical axis intercept. Vertical axis intercept. That's where our line crosses or meets the price axis. What's that? What's quantity demanded equal to at that point? 0. This is where, and I'll show you this in a second, where quantity demanded is equal to 0. I'll just check chat. No, I'm good. Now you guys, I've got a few in the room now. So tell me if, I'm really, for everyone who's just kind of come into the room, I'm just giving a very basic introduction to demand. I'm not doing anything too complicated this week because I'm away from my usual residence. So we're thinking about demand equations, and now I'm thinking about drawing a demand equation. I've got 120 minus P here. And I'm making the general point that the vertical axis intercept is going to be where our line hits our price. That's going to occur when quantity demanded is equal to 0. So I'll just rewrite this because it looks a bit messy, doesn't it? Where quantity demanded is equal to 0. So, and again, I'll just make this point for those, for those who, because this isn't obvious for everyone. Any point on our axis here is described in relation to, the price coordinate and the quantity coordinate. This point is described with reference to the height and also to the kind of the length or the width, right? So it could be this price, whatever it is, and this price. So what am I talking about with the intercept? Well, I'm saying if we're thinking about a whole line, it's going to hit the price axis when quantity is equal to 0. Okay, the vertical axis intercept is where quantity demanded is equal to 0. So in my equation then, I can tell where it's going to hit the price of the vertical axis. I'm going to set QD equal to 0 in my equation. So I've got 0 is equal to 120 minus P. We can plus P to both sides. P is equal to 120. So I can tell that when my demand curve hits my price axis, the price is going to be 120. Now, the horizontal axis is going to be the same thing we're thinking about, and this is true when we're drawing any sort of function or equation. We're going to think about where it hits our quantity axis. Well, that is associated with a price of 0. So our horizontal axis intercept is going to be where P is equal to 0. Okay. Good. So in our equation then, I'm going to set P is equal to 0. And I get QD is equal to 120 minus 0 is equal to 120. I'm going to cough in a minute. Sorry, everyone. sorry. 120. Okay. Now this is a linear function. I can intercept. I can tell you why it's a linear function in a second, but I just know that they're going to, I can join these up, and that's going to be my demand curve. It's a good way to draw a demand curve by finding the vertical axis intercept and then the horizontal axis intercept and joining them up together. Okay, good. Okay, so that's a demand. Now, here is an important point. Now, when I have demand proper, so I have quantity demanded expressed as a function of price, it is not in this form that we are introduced to in high school, which is called the slope intercept form of the equation of the line. So that would be something like this. I'll get pink. Y is equal to mx plus c, or b, or b. So when we are given this equation, it's a very important form or way to express the equation of a straight line. And when we have it in this form, with x on the horizontal and y, if we had any sort of straight line, we can describe that line. The slope will be m, that's the coefficient on the x, and the y-axis intercept will be b. So one of the biggest mistakes that students make is that they see a demand equation, like this, for instance, and they think, oh, the price axis intercept is, and I'll actually give you another example because that's a very poor example of you'll see why in a second. If I had a demand equation, QD is equal to 15 minus P on 3. So the coefficient on P is -1/3, and the constant is 15 in this equation. And so the biggest mistake that is made by students around this stuff by far is by seeing this and thinking that this is the price axis intercept and that the coefficient on P is -1/3, that's the slope. But this equation is not in this form because this y is the vertical axis variable, but q is always on the horizontal axis variable. So actually, in order for it to be in this general form, that slope intercept equation of the line, that canonical form, we need it in the inverse demand equation format. So we would need to work with this guy. I'll do it down here until price is on the left-hand side. So I can do this here. I can take away 15 from both sides. QD minus 15 is equal to, and we're left with -P/3. And then I can multiply both sides by -3. And so this would cancel out. I'm left with P on one side. I can put it on the left. And then -3 times -15 is 45 minus 3 times QD. Now this is an inverse demand equation. It's got price on the left-hand side. Price models it as function of quality. As price modeled as a function of quantity, price is on the vertical axis. So this guy here describes the same line as this one, but it's in this form. So I can tell from this equation that the price axis intercept is 45 and the slope is -3 for this one. All right, I'll see how I'm going. Yep, good. Let me know if you have any questions or if you want me to go through anything in particular. I'm just doing an introduction to demand here. And that's it. I'm happy to do something else though. Okay, so inverse demand equations, being really careful with this. The application of the lessons that were described in our high school so vigorously, being careful about where we apply that to, not to our demand function, but to our inverse demand functions, if we need those lessons at all. But as I showed before, we don't even need that to draw this demand, right? I'm drawing this one here. Okay, good. So that's our demand equation for Katie. So what did we see here? We said if the price was 50, quantity demanded was 70. So let's find that point here. That would be maybe somewhere like this. I'll use another color. Maybe it'll be something like this. here 50, and quantity demanded is 70. So when we substitute different prices in, we basically find particular points along our demand curve. Okay, good. So that's demand equations. Drawing demand equations, find the vertical and the horizontal axes intercept. Be careful with your application of the slope-intercept form of the equation of the line. All right, good. Now, I've been talking about, if you guys weren't here for the previous screen, I've been talking about Katie's demand for apples. So an individual demand for apples. Let's think about how market demand is formed, okay? So I'll go to a different screen, and I might just take some of this with me. If you just bear with me. Here we go. That should be good. So Katie's demand for apples, an individual named Katie, that's her demand for apples. And her equation of the line we said was QD is equal to 120 minus P. All right, let's say that there's another person as well named Monica. Monica's demand for apples was, and if you're at home, try and draw this one out. So I'll put this one here, Monica's demand for apples, and I'll put it in blue. QD is equal to 240 minus 2P. All right, so if you're at home and you're engaged, try and draw this one out. I'll draw out Monica's. The reason why I'm getting 2 here is because when we have a description of our consumers' behavior, sometimes we want to construct a market demand curve. So here we have individual demand curve. A market demand curve is found by summing up the conjunction of many individual demand curves. So I'll show you how to do that. So market demand is found. It's called the horizontal sum. Horizontal sum of everyone in the market. Sum of individual consumers. Individual consumers. Demand. Okay, so we have Katie's, now Monica's. Also says P and QD. Good. And I'll label my origin. Okay, so here I can think about it quite quickly. For the price axis intercept, we said before the price axis intercept, where our curve hits the price axis, we find that by setting quantity, that's where quantity is equal to 0. Just make sure no one's asking questions. Yes, exactly. Thank you. What's the max operator? Hello. Has it been a long time? I can't remember. I'm so sorry. Oh, like the max, like, I'm not quite sure. Good. So, very good. Okay, so with 240, so the price axis intercept, if QD is equal to 0, then we have 0 is equal to 240 minus 2P plus 2P to both sides. 2P is 240, P is equal to 120. Same price axis intercept as Katie. So that's 120. The quantity demanded axis we're going to find by setting price equal to 0. So if price is equal to 0, quantity demanded is equal to 240 minus 2 times 0 is equal to 240. So that will be very long, like up here. Okay, here we go. And maybe even I could do it longer. We'll see. We'll see if I can make it believable, guys. 120. Oh, sorry, 240. 240. Okay, very good. So now when we think about the market demand, let me put these ones together. And I'm actually going to just put everything a bit smaller, and I'll get rid of this working. Okay. Here we go. There we go. QD. P, we're going to think about summing up these two demand curves in order to make a market demand. Let me get my orange market demand. Market demand. And the key is here is the market demand will be the sum of what these guys demand up. We're going to imagine that Katie and Monica are the only two people in this market. Right? At the same price of $50, Katie demands 70 and Monica demands 140. Monica demands twice as many? I think so. Because it's so I'll just confirm that. The question was, what happens to Monica's demand at 50? That's a good question. So at $50, quantity demanded is equal to 240 minus 2 times 50 is equal to 140, indeed. So let's put that, and that can help us later on. So let's put that at the price of 50. Here we go. We found that 140. Good. All right, we can check with our market price. So then the question is, what happens in the market at $50? If Katie and Monica are the only two people in the market, what happens at the market at $50? That's the question. And that's really what we're doing when we're finding market demand. When we're summing them up, there's really two perspectives. There's visually what's happening, and here actually we can do a lot of work there. And then there's algebraically. So visually we can see that when the price is equal to 0, quantity demanded is, well, by Katie, 120. Quantity demanded by Monica is, well, 240, right? 240. So in the market, when price is equal to 0, how much is demanded? Well, Katie demands 120, Monica demands 240, so 360. 360. Okay, so at price is equal to 0, 120 plus 240 is 360. At price is equal to 0. Okay, well, at price is 120. Katie demands 0. Monica demands 0. So that's going to be the maximum price that is borne in the market. 120 as well. Okay. So we can draw our market demand in this particular case without even going near a mathematical equation. Okay. This is market demand, the horizontal sum. It will be steeper. And this one, Monica's demand, I didn't really draw it very well. It should have been flatter. Well, this 240 should have been out a bit. You can see that the distance between here and here isn't great, but hopefully it's illustrative. This is our market demand, the horizontal sum. Now, algebraically, we can find market demand by, we'll say QM is equal to the demand of Katie plus the demand of Monica. And here we need to make sure that we are adding up the demand curves, not the inverse demand curves. Because when we're adding up the quantities, we're thinking for every price, you know, we need the quantity demanded by Katie plus the quantity demanded by Monica. But, and here I'll put Mon, and this is Katie, because it'll be QM twice. Okay, so that's what we're thinking about. If we had inverse demand curves, inverse demand equations, and we added them up, we would be adding up prices, which we do that for public goods. It's called vertical summation, but it's not horizontal summation. So as a trick, you know, your lecturers might give you a demand equation, but it's got P on the left-hand side. and you'd have to rework it until Q was on the left-hand side before you added it up. Okay, so the quantity, the Katie, well, that's just here, 120 minus P. And Monica is 240 minus 2P. I'll just check the... Why is our prep always drawing the argument on the x-axis? We never had the argument on the y-axis. Why is our professor always drawing the argument? What do you mean the argument? I think that you're using a word here that I'm not super familiar with, the argument, mathematically. Let me check. I can check. No, that's not going to work. Oh, like an independent variable. Is that what you mean? Yes. Here. Really? Is that true? Really? I have never seen it done like that. That's really interesting. That's really interesting. I'm just gonna turn off monetization because I turned it off before, but it didn't do it. Sorry. That's really, really interesting. I've never seen that. So I think that's really interesting. I've never seen that. You draw the inverse function, you have price on the x-axis. I've never seen that before. Wow, does that confuse you? Because like, is all your literature like that or just your professor? That's really cool. That's like, it's not cool. That would be confusing for me. Okay, good. So that would be equal to 120 plus 240 is 360 minus 3p. So that would be our algebraic representation of our market demand. Okay, very good. So that's a fairly easy way to sum up. That's an easy case. Here's a more tricky case where there will be what we call a kink in our demand curve. So market demand with kink. Demand with kink. Okay, so I'll give you still, let's say Katie is still described by the equation QD is equal to 120 minus P. And Mon, instead of the equation that we had before, let's say that Monica's demand is now 120 minus 2P. Okay. So Katie's is still going to be the same as before. We're still going to have this. Let me just take Katie's there. That's still going to be Katie's, but we're going to have to redraw this new demand curve for Monica, which is different from the one before, and it will make a more complicated case. And I'm going to try to be very good with the dimensions this time. We'll see how it goes. So everything P and QD, except this is Monica. So when price is equal to 0, I'll just do it quickly. When price is equal to 0, quantity is 120. Before it was 240, right? Yes, I think it was 240. Oh, so yeah, when price is equal to 0, quantity is 120. When if quantity is equal to 0, so this will drop out, with plus 2 to both sides, so 2p is equal to 120, divide by 2, and now the price is 60. Okay, so if we do that, Okay. And what I can do now is I just put, that can be Monica's demand, maybe like that. Yeah. Okay. And now I'll just write everything down. So this is Monica's demand, Mon's demand. Okay, so now when we add up these demand curves, note that something has happened here, and I forgot to do something before, I just realized. That the prices in which they stop demanding is now different. In particular, Mon only, the maximum price that she'll bear is 60. If the price was any higher than this, she would not buy any apples. Yeah. But for Katie, it's 120. So in the market, the highest price that can happen is still going to be 120. But for prices, it's only for prices below 60 that both Katie and Monica will be in the same, but that they will be in the market. For prices between 60 and 120, only Katie's going to be in the market. Mon will not be in the market. Does that make sense? See how many people I've got. It is like that, like a common thing in microeconomics. Oh, really? Wow. That's really interesting. Um, yeah. Wow. I'd like to see that. That would be very cool. We're talking about in Australia, in all the textbooks that I've ever seen, quantity is always on the horizontal and price is always on the vertical. But I have a user from Germany, and they're saying that it's switched around, which is just crazy. Okay, so we're saying for prices between 60 and 120, only Katie engages in the market. Engages in the market. Okay, for prices below 60, Katie and Mon. So it's like we had before. Katie and Monica engage in the market. So we've still got the same kind of thought that, at the price of 0, Katie demands 120, Mon demands 120. So in total, they will demand 240. Okay. But really, we have to think about what's happening to Katie here at 60. The top half of the market demand will look exactly like Katie's, because only Katie is engaged in the market. And then at the price of 60, well, at that price, if price is equal to 60, Katie's quantity demanded is 120 minus 60 is equal to 60, right? Is equal to 60. So at the price of 60, Katie demands 60. Mon demands 0. 60 plus 0. That's what we're doing. 60 plus 0 is equal to 60. So at the price of 60 in the market, 60 is demanded. And then we've got at least graphically everything that we need to make this market demand. We are there. It would be something like this. There we go. This is our market demand. Let me just label it. I'm always in a rush to get everything finished. Market demand. So we have a kinked market demand here. As a result of this happens when our individuals in our market stop demanding at specific prices. They stop demanding at different prices. QM is equal to 90. I don't know. Maybe at price of 50. We were trying to figure that out before, and I forgot to show you what happened in the market in the previous one. Um, so that's our market demand. Algebraically, let's think about algebraically. QM, market demand, is equal to QKT plus Q Monica. I'll just, the quantity demanded by Katie and Monica if the price is lower than or equal to 60 and greater than or equal to 0. But for prices above 60, the market demand just looks exactly the same as Katie, is equal to QKT. If the price is below or equal to 120 or above 60. Does that make sense? I hope that makes sense. And then what we can do is we can substitute in QKT plus QMON. That's 120 minus P plus MON was 120 minus 2P, right? Minus 2P. 120 minus P plus 120 minus 2P is equal to 240 minus 3P. And is equal to QKT, which is just 120 minus P. So that's how I would do it. The KT and MON together, if the price is between 0 and 60, inclusive, or if the price is between 120 and just above 60, if the price is greater than 60 or less than or equal to 120, the market demand is equal to 120 minus P. So it's in two sections because we have this kink. Does that make sense? What do you guys think? It was actually a bit, what software am I using? I am using Sketchbook Pro. Makes sense. Let me know. Yes, okay, good. Sorry, it was a bit messy today because I've been away and it's so hectic to be away. So next time, I think next week I won't be able to do one because we're still away. And then someone has they want to do Solo Swan. Solo Swan. And I would like to do a good job of it. I should probably I would like to do a whole video series on Solo Swan, but I think doing a nice live stream is another way to get through the material and to get feedback on what's important for you guys. Is there anything else? If I look back to my original aims, I don't think I'll go through anything else. Demand schedules, demand curves, market demand, kinks, market demand. There's two things that I didn't go through today, which I, would probably, if I was going to, if you guys were going to think about trying to understand the very basics of demand, that shifts versus movements along, that's a really important distinction. And then the interpretation of demand as willingness to pay or marginal benefit is another really important interpretation. But I'm happy to, like, if you guys hear, did you send me an email about it? Did you send me an email? When did you send me it? I don't remember giving you an email. Or maybe it was like 2 months ago or something and I've forgotten. So do you feel better now about Solo Swan or about demand? Oh, today. I haven't seen it. Oh, great. Let me have a look. Oh, I can't see anything. I don't have anything unless you've gone into the promotions tab of Google. Anyway, maybe it's just coming through. I'm not sure. Let me have a look at the Econ Math Help. Yes, I'll write it. Econ Math Help at gmail.com. And what was it? Was it about Solo Swan or about demand? Econ Math Help at gmail.com. I wouldn't know how to add up a demand curve. I suppose you do it horizontally about demand. So what we did today was that no, I don't think it went to spam. Nothing ever goes to my spam. I've got nothing in there. It just goes to um it just goes to promotions. You know, there's like a promotions tab. It's just like which has got so much stuff in it because everyone's always asking me to sign up for stuff. Ah, okay. Inverse aggregate demand curve. So was it like what I did today, or it looks different? I'm just gonna. I've still got a few minutes. I've got a student in a bit. Inverse market demand. Just. Let me see. No, I didn't get your email at econmathhelp at gmail, but I think it was econmathhelp. No, I didn't get your email. Anyway, send it. So it's this one, econmathhelp at gmail.com. But yeah, it didn't come through. So send it again because I'm interested. So did what I do today, is that what you're doing in class? I'll check. Oh yeah, okay, I got it. Simon. Okay, let me have a look. I see. Okay. Oh, okay. That's what you meant by max function. I thought that maximum. That's okay. Q is still on the left-hand side. Yes, okay. So I'm looking at image 1. So this seems to be the same as what I did today. They've just used this max function. What do you think? Especially that last picture. So I'll just explain for. Do you mind if I put the notes on my whiteboard? Yes, this is exactly what I did today. I'm not sure why they use the max function. I can't interpret that here. Not the common and right way in Germany. You should do it differently because in the second example I sent you, it is like this. It is like it should be done. Yes, that's what I think. I mean, he's doing exactly the same thing. Let me just here. This looks like, yes. So what is he doing? Okay, so I will explain. I think I understand what he's doing with the maths. Hang on. So I think it will come up in a second. Okay, so I think here, quantity one as a function of price. So that's fine. This is good. Um, it's the maximum of. So what the reason why he's using this max here is because when I draw a demand curve, I stop, and we do it because we're in economics. We ignore negative prices and we ignore negative quantities, right? And then I'll say, yeah, this is 100. This is 120 minus p. Q is equal to 120 minus p. But this drawing here is actually not a drawing of 120 minus p. 120 minus p looks like this, right? Do you understand? So he's saying the demand is equal to the maximum of either it's going to be this or zero. Because for some prices that are too high, quantity will end up negative. And he's saying just very formally, we don't want, if this argument comes up as negative, then demand is just equal to zero. That's what he's saying with the max function there. Does that make sense? I'll have a look. That's right, exactly. So we don't get negative demand. So it's just being actually more careful with the um, notation, whereas most of the time we just assume, usually we just don't take it as part of the model that quantity or prices can be negative. So that's what they're doing. Does that make sense? So in the second example that you showed, it was done like how I did it just then in the live stream. But here, using the max function, he's just being more careful actually. He's just saying, look, if you get a negative, it just means that the price is too high, so demand is equal to zero. That's all that means. Does that help? So then you would say here, and we can just do it kind of quickly. Q1 of P, I'll just keep these notation, is equal to, how I would do it is like this. This would be Q1 and Q2 is equal to 1000 minus P on 2. And so we have, so person 1, person 2, and person 3. And I can see in the other parts that you sent to me as well that the way they've done it, they've actually, when I wrote out the demand, I only did 2, right? They've also added, your tutor also added QM is equal to 0 if price is above 120. They've put it in 3 bits. So he's been quite formal about it, more formal than wherever I've taught, but maybe we're very informal. Australians, I think, are known for being informal, right? So price. If I did this quickly, the price would be 1,000, 1,500 here. This would be person 1, 1,000 and 2,000. If Q is 0, P is 2,000. If Q is 0, P is 1,000. 2,000, and if P is 0, 1,000. So then you'll do it like this, and then the sum will be 1,500, and then at that 1,000 there's going to be, we're going to see what happens to person 2. If the price is 1,000, this is 500. Terribly terribly rushed. This is 500, and so then you would get a kink. The highest price is 2,000. Let's see, is that what you got? Yeah. And so you would get a kink like this. Does that help? Where it says the inverse. Let me have a look. Take a negative. Yeah, so the max function, so we don't get negative. The second example, where it says inverse. Let me have a look. Oops. 500. Okay, so I can't see the word inverse. Demand. Oh, I see. Yeah, so what happens if we invert it? Yeah, so they're saying don't invert it. Yeah, I can see from the German. I can see don't invert, because what happens when we invert it? Okay, I'll explain what happens if we only use the inverse demand function. So if we had P is equal to 50 minus Q and P is equal to 50 minus Q. So this is person 1, and person 2. The question is, okay, so they're identical. That's fine. That's good. Or let's just say it's 100 minus Q. Let's say it's this. 100 minus Q. So 50 minus Q person 2 is just 50 and 50. And 100 minus Q is this one. 100 and 100. Easy. 100. So that would be our 2 people. And I mean, you can do it on one axis as well. I've been doing it on 3 axes, but you can just do it on one. And the question is, okay, we've got inverse demand curve here. So price is being modeled as a function of quantity. The question is, what happens if we just add the p's? So we have 100 minus Q plus 100, or 50 minus Q, right? Minus Q. Well, what are we doing then? Theoretically, I mean, kind of technically, we're not saying at the price of 0, you know, person 2 demands 100 and person 2 demands 50 and person 1 demands 100. So in total, in the market, 150. This will not give us that if we just add up the inverse demand functions. What we will get is this. We would be adding up vertically. So we would be adding up. It would be, the sum will actually look like this. So this is vertical summation. And you will not get, instead of horizontal sum, if we add it up here, then I'll just change it back. Well, it was 150 minus 2Q. P is equal to 150 minus 2Q. That would be this red line here. And that would not be correct. That would be saying for every quantity, what is the sum of prices? Not for every price, what is the sum of the quantities that are individuals in our market? Does that make sense? Let me have a look. I haven't looked at the thing. Yeah. So you cannot add the inverse demand functions. The inverse aggregate, this one, to add the aggregate, this would be thinking we actually do this for something called public goods. And we do this when we want to think, you know, so if you had a national park if you had a national park, right? So beautiful area where lots of people can come and they can have picnics and take their family and have parties and everything, right? If we want to understand the value that one national park or one playground has, right? We are going to think about, if that was one, for instance, we're going to think about the value of person one who uses that, plus the value of person two who uses that, plus the value of everyone. So instead of thinking about market demand, when we're thinking for each price, what is the sum of the quantities that each person demands? We're thinking for, when we're doing a vertical sum, it's more like thinking for this particular quantity, what is the sum of the values? So when we sum up the inverse, we're actually doing something called a vertical sum, which is appropriate when we're having public goods, when we're thinking about the sum of the values that is um, given to a good that can be enjoyed by many. And this is a very different thing to finding market demand, where we're thinking about, for all the prices, what is the sum of the quantities? Does that help? Does that help? It's actually a very cool thing to do. It's just, so let me know. So we have to make sure whenever we add up our demand functions, we are adding up the demand functions and not the inverse. Which cases? But what did they do to get the cases? Distinction with Q. Oh, I see. Mm. That's in the second example, right? Yeah, in the cases here, we're only talking about X1. Does that make, is that what you're like, good one? The distinction with Q. Yeah, I'm not sure I understand the question. Yeah, only good one. Exactly. It's kind of a um well, we're only talking about one good, right? We've only got Q on the horizontal. Um, except you might have to distinguish between the good that is Katie's demand and Monica's demand or something like that, if that makes sense. So here, I'll just try and put it back. Yeah, so we would have Q1 and Q2 added together to make Q market demand. Um, just in the way that I was taking this to be Q Monica and this to be cue Katie when I had it up. Yes, but maybe I'll have a proper read through your email because I found it now. And then I'll try to understand the exactly the question. I'll try and read the German. It's quite similar actually. You can see. All right, guys. Well, I'm gonna leave because I've got a student. I hope that helped. Um, and great. Yeah, so just uh on my channel page, you can go to posts and see when the next one is, and you can always request to go over specific topics. And you can email me as well, as provided that it goes through. And then it's good. All right, well, have a think about it. And it's so nice to talk to you guys. I will talk to you next time, maybe, and hope you guys are doing well. See you. Bye.